them to you, and we'll also post them on YouTube. So nothing is hidden. You'll be able to get all the information that you need. We have about an hour scheduled. We can go a little bit long if we need to, depending on the amount of questions that we have. But we have a lot to cover. So I'm going to go ahead and jump right in. So as a way of introduction, my name is Matthew Shear. I'm a marketing manager here at Rancher. I host these training sessions and many others that we do. You can use me as a point of contact at Rancher if you are looking for a resource, if you're trying to find a presentation or have some question, don't hesitate to reach out. I included my email address, matthew@rancher.com there, and also my handle on the Rancher user Slack, which is just at Matthew. I'll talk a little bit more about the Rancher Slack in a moment. I think many of you already know about it. But the man who's really going to be doing the heavy lifting on the line today is Farhan from StorageOS. Farhan, are you there?
Hello everyone.
Awesome. Hey, Farhan. I'll let Farhan introduce himself a little bit more as we go on. I just want to get through a couple other housekeeping items before we dive into the main content. Like I said, this is about an hour, 45 minutes, 75 minutes. We'll just see, depending on how many questions we have. We try to be as responsive as possible to what you all want to learn in your particular setup and learning journey. So please do ask questions. We have saved a lot of time at the end, built in a lot of time at the end to go through an extensive Q&A. But we might pause during to take questions, and I will do my best to answer questions in the chat as they come up as well. So please go ahead and start putting your questions into the chat. If for whatever reason you want them to be private, just let us know. Otherwise, I'll ask them aloud for everybody's benefit, and we'll answer them aloud so that everybody can learn. As I said, the session is being recorded. We'll post it on YouTube at our Rancher channel. We have a lot of sessions, our master classes, our intro trainings, our online meetups. We do a ton of virtual events and even more these days. And so we post them all on YouTube for everybody to see. And as I mentioned before, our user Slack is thriving. We have a huge community around these technologies, Rancher technologies and others, a lot of open source users here. If you go to slack.rancher.io, you'll be able to join. It's totally free, thousands of members, hundreds of people asking and answering questions every day. We also have a masterclass channel where we post upcoming news and files or anything else that might not make it into the email. So that's all I have. So now that that is out of the way, I'm going to pass this presentation off to you, Farhan, to make you the presenter. Make you presenter. Let's see.
Cool.
Yes, there you go. You're good to go.
Fantastic. Welcome everyone. Thank you very much for the introduction as well. My name is Farhan. I work at StorageOS. We mainly do storage for containers. So today we're going to be talking about high available WordPress powered by StorageOS on a Rancher cluster. I'm going to use WordPress as an example of a very well-known application across the business on how to use what we call, or what is called in Kubernetes world, read-write many volumes. Also because it allows me to use different components. We have a database, we have a web application, we have a shared file system, etc. So it's just an example of an application, but take it as much as you can. So if you want to ask questions about WordPress, feel free. If you want to ask WordPress a bit of questions a bit about more generic, also feel free. My background mainly is about systems engineering and DevOps. So I guess most of the people in the call is going to be also in that audience. And yeah, we work systematically with Kubernetes and in the UK, in London. So let's start with this. So I was saying the main components we're going to use today are WordPress. We're going to use Kubernetes cluster powered by Rancher, and I'm going to show you the details in a bit. Essentially, we're going to use WordPress deployment. To be able to power that WordPress, we will need a shared file system. Why is that? Well, if you think about standard web applications that hasn't been designed yet for microservice architectures, they usually need some sort of shared across all the instances of the applications to be able to serve assets, for instance, things like images or JavaScripts. It's true that there are plugins available in WordPress that allow you to do that through object store like S3. You can redirect URLs, but essentially there are many applications. If it's not WordPress, maybe Drupal or your own self applications that require this shared file system. And we're going to show today how you can achieve that on a high available manner on Kubernetes. Then we will need obviously a database for WordPress, which is essential. And we're going to deploy this database in a way that you could deploy a Postgres, you could deploy any other stateful applications. So first of all, we're going to have a cluster. We have a Rancher server that is going to power a few of Kubernetes clusters, and there are a few nodes. So let's start. I'm going to use StorageOS to power that high available storage backend system, and we're going to install StorageOS on every node. StorageOS installs as a daemon set. Essentially, there are a few other components, but the main, the core of the solution installs one pod per node. So let's go and let's do this, and from there on we're going to move. So I have two clusters. One with 4 nodes, one with 3 nodes, just to be able to be a bit faster when we do things. I'm going to start with demo 2 installing StorageOS in this node. So in this cluster, we have 3 nodes, happens to be both of them in GKE. They could be in Amazon, they could be in bare metal. These happen to be in a managed service because Ranchers allows us to do that. It's actually really, really easy to create clusters across clouds and across the board. So how I'm going to install StorageOS is using the Rancher application here. Let me show you. Let's go to the marketplace, applications, launch. So StorageOS. So from here, what we're doing is telling Rancher, please deploy my StorageOS cluster. To do so, we use what is called an operator or a Kubernetes operator that StorageOS has implemented for its own solution. So here there are a few things that we can start defining. Is a custom resource that we will fill in a form way or in a form base. So let's have an admin and a password, for instance. There are a lot of information here. If you want to go in detail or have any questions, just post it in the question section. More than happy to go through it in a bit. But essentially, let's see. We're going to deploy StorageOS. Let's put a key value store. And there are a few options that we can choose, node selectors, storations, the namespace that StorageOS will start, etc. So let's launch and let's see what happens. So now the StorageOS operator is starting, and that will translate into different components. One of them is the daemon set I mentioned before. To go a bit faster, this takes maybe around 3 to 4, maybe 3 minutes to go all together and have a cluster up and running. So we have in the other cluster things up and running to save a bit of time. So let's go and let me show you exactly what is happening. So on the other cluster that is already deployed, we have one StorageOS operator. It's one pod, and that pod will interact with Kubernetes to create resources for you. So in this case, based on that form, we have tell the control plane of Kubernetes, hey, this is how my StorageOS cluster looks like, and it's going to go and install it. So we go and workloads. In the StorageOS namespace, because I specified that before, we'll have different components. And as I said, mainly we'll have a daemon set. I have 4 nodes in that cluster, so we have 1 pod per node. In addition to that, StorageOS installs the StorageOS scheduler and a few other components. The StorageOS scheduler, I'm going to show you a bit later, is a way to influence the Kubernetes scheduling decisions to guarantee best performance or to collocate pods and data. So cool. Now we have a Kubernetes cluster. We have a Rancher server powering our control planes and our Kubernetes. These are deployed in GKE. We have StorageOS installed. Let's go and have a look into the StorageOS UI to see actually that StorageOS can see all the nodes. So in every one of these spots, StorageOS serves the user interface. I port forwarded this. Can show you later how to do that if you're not familiar with it. But essentially, I'm connecting to this cluster to see the StorageOS spots. So we can see that actually we have available 50 gigs in the StorageOS user interface. We can see different nodes. So we can see the 4 nodes of the cluster. So we can see that now we have the capacity available to start provisioning data for containers. Cool. So we have installed this. StorageOS has uses the host capacity available. So the disk available on every host is now used by StorageOS. Of course, you can select which ones and which not. For now, for simplicity, I'm using the root file system, something very simple. So StorageOS is aggregating that capacity. So it's taking all these nodes into one main pool. So now we have around 200 gigs of data available to give to the containers. Cool. So now we have a bit of context. Let's keep moving. So what StorageOS essentially is, and this is, I'm going to give you a bit of context. I'm not going to go in detail because we're going to focus on the WordPress solution and the solution itself. However, to be able to provide the high available solution that we want for our web application and for database, this is what is going to power that high availability, that production ready system. Why? Because StorageOS is a software-defined storage engine designed for production workloads in Kubernetes. So essentially, it gives us the persistent storage for containers, a completely transparent interface with Kubernetes. It's essentially block storage. So the main use case is block storage, let's say MySQL, Postgres, Elasticsearch, but we also have implemented a proof, we released a beta for read many volumes, so for shared file system volumes. And this is what we're going to use today. We're going to use this solution that powers the block devices in addition of a shared file system solution. Just to have a bit of context, if you're familiar with Kubernetes notion in terms of the storage, you know what the storage class most likely is, you know what the persistent volume is, you know what the persistent volume claim is. However, this tends to be quite a detailed information in terms of your Kubernetes knowledge. So just in case that you don't know, I'm just going to recap really fast on the 3 main components of the storage system in Kubernetes. So first of all, we have an administrator user that can register or create storage classes. Most storage providers, and storage is one of them, already deploys a storage class when it's created. By the way, I'm going to use K instead of kubectl to make things faster, to type a bit faster. So get storage classes. It's going to show me which storage classes we have in the cluster. So for instance, the default one is created. We can define these in the form that I showed you before. And we have another one that's called replicate, StorageOS replicated. What the what the storage class is. Is no more than a way to tell Kubernetes what is the provisioner and passing some parameters to that provisioner, some information to be able to connect Kubernetes to a storage provider or provisioner. So what happens, what we can do with the storage class? We can start provisioning capacity. From that storage class, we will have namespace users. They don't have to have access to the whole cluster. It's not cluster-wide, it's namespace-wide, that we will start asking for data. The way to ask data is through persistent volumes, and then one layer of indirection more, persistent volume claims. Today, because we are using StorageOS, we're going to use only persistent volume claims because StorageOS will dynamically provision anything under the hood that is needed. So we will have a claim. That claim is asking to that storage class a chunk of capacity for a container. When that chunk of capacity, that space is provisioned, we'll have, in this case, StorageOS giving the mount to the kubelet. So the pod will be able to start and mount a volume. So today, what are we going to use today? We're going to use the read-write many volumes. As I said before, the volume can be mounted as read-write by many nodes. So essentially, imagine an NFS. If you think how a shared file system works with all the goods and the bads of it, it's common that we need this for containers, even though not many people like it or think that is the most elegant solution. Almost everyone, for one requirement or another, needs a read-write many volume. So we're going to use this for the document root of the WordPress. The only thing we have to do is just specify the access mode into the storage class that we're already referencing in StorageOS. So this is Kubernetes transparent, this is very simple, and StorageOS will handle everything under the hood. Then we will need the read-write once volume. Why? Because we want a database, we need a MySQL. And of course, we could use more components for this WordPress. If we could say for production, we would use Varnish at the front, we would use Memcache or Redis for sessions, or if your plugins in sessions, etc., etc., etc. However, today we're going to focus on high available input-output operations or high available application, and from there on, you can build up as well. So we need, for the MySQL, we'll need this persistent volume claim that is block device. So there are two main differences in them. Block device means low latency performance, high throughput, low latency input-output operations. So we have some requirements that mean that only we can mount this volume into one pod or one node at a time. What would happen if you could start different processes, different MySQL processes against the same file system? We would break the database in really easy. On the other hand, we will use a shared file system based on NFS to use the document root. If you're familiar with WordPress, most likely you know that WordPress, you don't usually create the document root and you share the document root. You flash through your CI/CD, your source control based application, and then only the uploads directory where you need actually that shared space will be shared. Today, for simplicity, I'm going to use the whole document root. But I know, and I think you most likely know, that there are only some parts of the application that need to be shared. So let's go and let's get into the command line. So let's start. We have the cluster. I'm going to use the 4-node cluster so you can see the volumes. The repository I'm using is publicly available. So let me show you. Is the use cases of StorageOS. I'm going to use quite standard YAMLs as well. So first of all, let's create a namespace for WordPress, which I believe it's already there. Yep, it's there. You can verify that there is nothing in that namespace. It's empty. That's good. So now let's go and create the application and see how we interact with it. By the way, in this use case repository, we have a lot of examples. There is Postgres, there is a way to persist Prometheus, synthetic benchmarks with FIO, Jenkins, Elasticsearch, etc., just to use in Kubernetes with persistent storage. So let's use the WordPress. So we have two main components, the MySQL and the web application itself. SQL. Cool. So why did I just create it? Because now I'm just creating things to speed things up. However, let me show you in detail. Essentially, the important component here is the stateful set. Stateful set, if you're not familiar with that notion, is a Kubernetes controller for stateful applications. So it will help us to ensure that we have one pod and one pod only per instance of the application, mounting one persistent volume claim at a time. So we have this stateful set, really basic. We're using, I'm using a standard MySQL image, so nothing baked in. And we are mounting a volume into var lib MySQL, right? Which is where the database will store its data. Now, where is this MySQL data volume coming from? This is coming from a volume claim template. A volume claim template is a way we have in Kubernetes for stateful applications or for stateful sets to reference the persistent volume claim that needs to be associated to that application. So we will start a pod, and that pod will be associated to this PVC definition. And of course, we're using StorageOS. If you see here, I'm not using the default storage class. I'm using StorageOS-replicated storage class. And the access mode is read-write once, as we said before. Now, what does that mean? Why we're using this storage class? We can enforce with labels that the StorageOS volumes are replicated. So in this case, we're going to have one replica for the volume, and I'm going to go in detail later how we do that replication. However, the important thing here is now we know that we know that our database is using a persistent volume claim, SQL data, backed up by this storage class that uses StorageOS with a replicated volume. So we have one database, one persistent volume claim that is associated to it. And now let's go and have a look at the StorageOS user interface. We can see here that we already can see one replica in this node, and the primary volume of itself is started in a different node. So volumes. StorageOS, by the way, follows the namespacing. So in the StorageOS user interface, we can see that just by creating a YAML, just by creating a stateful set in Kubernetes, we have handled now through a declarative mode and through an application-centric principle, a block device that is replicated across two different nodes, right? Now we can see two things here. We can see it is mounted, so where the application is running is in a node that happens to be different from where the primary location is, meaning the pod is running in a node different from where the data is going to be stored. And you may think, why am I not putting it together? Well, I was enforcing this because I wanted to show you that. By default, StorageOS implements the scheduler, which I was mentioning before, which is a way to tell Kubernetes, try to put the pod in the same node as the data. However, if you cannot do that, it's okay. Just start it and let StorageOS connect through a network and through the StorageOS protocol internally to be able to access the data. So we have a pod that is running and is accessing data in its file system, in its var lib MySQL, in a different node. So let's actually have a look. So we can see that in var lib MySQL, there is a StorageOS volume mounted. And that volume is in that host, however, the data is in a different node. Now, let's go and create the application. This is a block device volume. So that MySQL can read and write to that block device normally. Now, let's create the MySQL, the WordPress. Again, I'm going to create it, and then I'm going to show you exactly what we're doing. The first thing, and probably the most important, is what we were talking before about the shared file system. So we're creating the persistent volume claim. That persistent volume claim is using one of the StorageOS storage classes, and is using read-write many as an access mode. That's the only thing we need to do to provision this NFS solution that I'm going to explain the topology in a bit. Also, we can define which level of replication we want. In this case, one primary volume plus one copy, so one replica, meaning exact two same copies of the data. And you can do this with all persistent volume claims using StorageOS. We can enable functionalities such encryption, for instance, just by adding labels to the PVC. So we have created this. So we can see that the deployment of the WordPress started. However, it cannot yet mount the persistent volume claim. Why is that? Because the persistent volume claim is being created. Let me show you this. So here we can see the database, we can see the document root, which is the PVC, and we can see another one. And I'm going to explain a tiny bit exactly what is this other one. But essentially, we can see that it's bound, so the PVC is already provisioned. And there is the database pod, the WordPress pod that are already healthy and started. And again, there is another one. What is this? This is the way that the StorageOS is using to share that volume. So what are we doing here? When we provision a read-write many volume, StorageOS will automatically provision an NFS Ganesha-based server that is essentially an NFS server that runs in user space, and that the StorageOS also altered. This is, by the way, open source, so you can go check out the full source code of this NFS solution. So we create a stateful set with that volume. Okay, now we have a stateful set that has data, that has an NFS server inside as a pod, and that is put together to talk to Kubernetes and provision the read-write many volume. So now we will see inside the WordPress pods what is in there. So let's go and have a look. So if we look into the mounts inside one of the WordPress containers, what we can see is that it mounts what it looks like an NFS, and it mounts into a document root, correct? Good. So now, where is this coming from? If we look at the service, when we deploy this pod, we get a service, and we can see here, that's the same IP. Now, we have an NFS server serving that endpoint for the Kubernetes pods, completely dynamic. We had to do nothing, just create the resources, and StorageOS handle all that lifting. And what I want to say is, now that we have that NFS server, what would happen if we lose that server? We need high availability for it as well. It's now not only the MySQL that needs high availability, is also the NFS server. So that's where this persistent volume claim is coming from. Is a StorageOS block device that is serving that NFS server. So let's have a look. If you're familiar with an NFS server, it's fine. If not, don't worry too much. Just bear with me a bit. In the /exports or in the export directory, we have the volumes that we usually want to export, and we can see StorageOS device being used for this volume. Because we enable replication, now we have two volumes, the MySQL one and the NFS one, and both of them are replicated. So in case of node failure, StorageOS will automatically fail over and give us our data back. And we're going to do that. So let's keep moving and let's start using that WordPress. So WordPress is running in this service. So I'm going to pour forward to access from my computer. Of course, in a production environment, you would want most likely a load balancer. So let's go and this one here. So I'm gonna port forward the WordPress service to the HTTP port to my local host at a different port. So let's go have a look. Good, we have a WordPress application. That is one of the main reasons that I use the document root itself rather than a self-implemented application, because I want you to see that once you put your applications in here, whether it's from your source control or from a default WordPress image, you can just start right away just by using the storage class. Good, we have a WordPress application. Now, remember, now if we're here, we have provision of WordPress. That means that we have a database. Good, that we can verify that that's working fine just by seeing the UI. We know there is a database provision in the MySQL. Now, let's go and add what is shared, what we actually need the shared for. Let's go and let's add, for instance, an image. That could work. Good. We could upload from my box to that cluster into the shared space an image. So let's use it so we can verify later that actually it's all good. And let's publish. So now we have an application that is running in our Kubernetes cluster that is serving a WordPress application through an NFS service for the shared file system, connecting to a database that is backed by StorageOS volume on a block device using replication. And we can see that all of these, in a matter of minutes, we can have it up and running. And all of these with high availability. And how we enforce high availability? First, we're running WordPress on at least 3 pods. So if I keep refreshing, I'm most likely hitting a different pod. However, you might say, oh, but the session or the browser might be caching, etc. Let's go have a look. We're in the document root of the application. WordPress content. So if we look into the application file system, we can see right away that the rancher logo has been updated. Good. Because we have deployed WordPress as a deployment, which, by the way, I haven't shown you, but it's a very standard WordPress deployment, which most of you probably already know. So nothing fancy here, just a bit of information of the replica, so how many instances of the application we want, standard image, as I was saying before. Most likely you want your own baked images with the source code, in addition of the volume mount, which actually is mounted in doc root. In a production use case with that source code, you could go into the content or document root /WordPress content /uploads, and essentially we're referencing that persistent volume claim. So that's pretty much it. Because this is a shared file system, we can use a deployment, and that deployment can scale easily. If it's a stateful set, for instance, for the MySQL, and we would scale that, we would create a new database with a new volume. But in a deployment, that's different. In a deployment, we can scale to have horizontal scalability of our application. Let's put 5 replicas. So now we had 3 pods, now we have 5. And why am I doing this? Well, this, for instance, just started, right? So let's go in. I'm going to show you something else. So we can see that we can scale that deployment right away. I just scaled the application. I started that pod and exec into it, so get a shell into the container and see that actually the load is still there, even if it's in a different pod completely. So no matter how much load we have, we can scale. That service will bring us the shared files. You might think, okay, what happens when I add too much load to that NFS? Well, what we are doing here, or the model that we're following, is we're going to create one of these solutions for every persistent volume claim with read-write many that you need. So we can see this guy here. For every PVC with read-write many, we will create one of those. So we will have one NFS server per persistent volume claim in the terms of read-write many. You can see obviously that for read-write one's volumes, that's not needed because that's enforced internally in StorageOS. So we will virtualize the presentation in between what the container needs and where the data is stored. So now let's play a bit with the data itself. We have seen that we have a database. We have seen that we have an application that can scale easily and have all the data, so we can keep serving our application. Now, let's go with something a bit more interesting. We see that, let's go to, for instance, the NFS service. We can see that the data of that NFS server, or even the database, could be, for the sake, could be the same, is running in a node. That is where the data is stored. That is where the replica is stored, right? So now we have 2 copies of the data. We use strong consistency through synchronous replication. So we have the same data at every point in time. Now, what could happen if we lose a node? What would happen if we want to move data around? What would happen if our application needs to start somewhere else? Let's go and have a look. Here it is. We have a node, BPMT, this one, this guy over here, that is holding one primary volume and is holding no replicas. If we look at here, we can see that there is replica in a different node, there are replicas in a different node, right? So happens to be that the primary volume is in a node alone. What happens if this node fails? What happens if we reboot this node? What happens if the network gets partitioned from this node? Let's go have a look. We have the node here, BPMT. Cool, I see there is many questions, so we'll be ready in a bit to answer them. So I'm into SSH into the node itself, and I'm gonna put it down, right? I'm just gonna reboot the node that has data that actually our database is being served from. The node is gonna go in shutdown. We can put it down in a tiny bit. Kubernetes will start see the node when it's it's gonna go down, so the node eventually will show as not ready, and StorageOS will see that as well. So let's wait for maybe a minute that all goes down. Cool. So let me go again. Cool. So our UI is ready again. and happens to be that the node is offline. Look at what happened to the data. Happens to be that there is no primary, no replicant that data in that node anymore. Why? Well, because StorageOS has detected there was a failure. It actually promoted. You see that there is a primary here and a primary here. Those before were replicas. It has promoted one of them and automatically gave that reroute the traffic through the database to that new node. So let's actually have a look. Remember that this is declarative, and this is, we try to be as cloud native or follow the principles of cloud native. That means that it is declarative. What are we doing is, well, we're missing one replica. I had a volume with 2 copies. What happened? Now I fail over one of the volumes. What happened to the other? Well, we started creating a new replica from scratch to enforce that the system self-heals. So if we go to the volumes, let's make this big again. We can see that both volumes are healthy. There is not much data, so the amount of syncing that it takes to replicate a tiny database is almost nothing. But we can see now that the primary volume of the database is in a node that before was where the replicas was being in sync. And here we can see 2 replicas. Like, well, but I had only one. Yes, happens to be the one is failed. Why? Because it was in that node that is gone. So we have the traces that there was something there that now is failed. And of course, the second replica that is in sync in a different node. So the system self-healed and forced that there was that copy that we're missing. Now let's have a look of what happened to the application itself. First of all, what happened to the pod? Because the pod was in a different node, it didn't have to restart or anything. However, it changed where the data was stored, and the pod sees nothing. The database container sees no restart, right? We can see, same as we saw before. Sorry. So we can see that our database has the data as available, but you could say, okay, yeah, database has the files, but the files in a database are a bit more complicated than these. We need to sync the file system, etc. Let's go have a look at the application itself. See if I haven't lost the forward. Let's do it again. Forward. Happens to be that the application is all good and happening. So of course my networking has failed because one of the nodes I was connecting has failed, so I re-triggered the connection. But we can see that our cluster has been serving all along. So we have moved data. We have failed a node hard. Yeah, it's a reboot, but it's not. And not we drained the pods. We didn't move the data. We didn't drain the data cordon. We just shut a node, right? And our application is still running. It's running no problem. So what we can see that all the pods, if they had to restart, they restarted. And if they had data that was backed up by StorageOS, StorageOS handled the network path transparently. So let's go and prove that the database is actually usable. Why? Because, you know, as soon as we use the backend of WordPress, we can verify that the WordPress database is up and running and safe, because actually that data is retrieved. There is no caching in the WordPress backend, in the WordPress admin page. Cool, huh? I know that many people don't like doing live demos like these where you shoot things, because people might think that things go wrong. Actually, that is what in production you need, right? So let me go here. So what we have done is create this shared file system, read, write many PVC, the MySQL pod, the MySQL PVC, and we backed up that through high availability. And all the application that we have used today has high availability in Kubernetes world because we're using StorageOS installed through Rancher. So you have seen that in a couple of minutes we have StorageOS installed. And now how that replication works, how can we ensure that data is safe? Well, when we start a container, StorageOS handles that network connectivity inside. That's why StorageOS is installed in all the nodes of the cluster. It doesn't have to hold data in that host itself, but it will have all the logic to do this kind of behavior. So every time we write to the primary volume, no matter if the container is in the same node or not, of course, for performance, we want it in the same node, but we don't have to. When that write happens, that input-output operation or that block is sent to the replicas. In this case, we have 2 replicas, 3 copies of the data. When they are acknowledged or committed to disk, we can go back to the file system inside the container and say, okay, this write is done. Yeah, these have latency implications for writes, but what happens in case of failure? As you've seen, StorageOS automatically fails over, and it reprovisions a new replica. That new replica is syncing, and in the meantime, we can read and write still to the primary volume, no problem. When it comes back up, we can start using it for high availability again. And that replicated so fast because the database was small, so we couldn't see that process during the demo where the volume was in sync. No, it was healthy already because it was fast enough to sync. Cool. Also, we've seen that even we lose the NFS, we lose the WordPress pods, or we lose the data that is serving the MySQL. As soon as we can use StorageOS for that, it handles all the connectivity on the back. One thing you haven't seen, because I wanted to play around and shoot things, is locality. And I put this here because this is a question that arises very, very often. So I tried to tackle that beforehand. We have the WordPress applications. We have NFS server. We have, let's say, that we need an Elasticsearch, and we're using StorageOS to back up the PVCs of Elasticsearch. We need the Redis. Let's say we need the MySQL as well. And for all of them, we're using storage, right? This storage is actually quite free in terms of provisioning. It provisions in a matter of seconds, if no less. But our applications, our containers starts really fast from anywhere. And it's fine. If they start through the network, StorageOS will give the accessibility of the data, which is a fundamental principle for production environments. However, what happens to that Elasticsearch or that MySQL that need low latency performance? Well, through the scheduler, every time I mount the StorageOS persistent volume claim, the StorageOS scheduler, this guy here, is queried and send a list of nodes every time that it said, oh, there is this pod that I have to schedule and it's using the StorageOS volumes, by the way, where should I put it? And the Kubernetes control plane, or in this case, it would go through the Rancher TLS or through the control plane of Rancher, it will go through that scheduler and say, okay, where should I put it? And we will try to put it close by the application. There are 2 modes, strict and preferred. By default, like today, I use the preferred, meaning if you can, because the node is cordon, because the node cannot schedule more pods, but it has the data, whatever it is, it's fine, just put it wherever. We will connect to the network, we will have low latency. And a strict mode means, no, I will not start that pod unless I can start it in that specific node because I need predictable performance, no network implications, which again is up to you on what you need. By default, by definition, without doing anything on default installation, StorageOS will try to put those pods close to the application. So to recapitulate a bit, what we have seen is we need a system for any production application. In this case, we use WordPress, and I think it's a fantastic example because WordPress is widely used, and you don't need much of infrastructure to it. But the data must be accessible from the application wherever it's running. So we have to enforce accessibility to the data. As soon as we achieve that, WordPress itself is very scalable, is stateless in general from the fact that if you sync that shared file area that we need as the uploads, as we shared before, that's all it needs. All the user management is done stateless, all the application itself works through the database, etc., etc. So you need, for a production system, in my opinion, a system that allows you to give accessibility to the data wherever it's running. Data for high availability in a production environment needs to be replicated. You might think, well, but mine is not a production environment. Well, now if you use this, it's free, right? In a way that you don't have to pay much or pay more for having replication or not. You don't have to enforce the lockdown in a container to a node. So imagine that you would use host directory persistent volume claims. If you're not familiar with that, it's fine. For those who have heard that, a persistent volume claim using the host dir is the most simplistic way to provision storage in Kubernetes, which pretty much means, look, I'm going to start this container and I'm going to use part of the file system of that host to store data of that application. That's it. That's pretty much it. Whether it's in /tmp, in /var tmp, you can, with some provisioners now, use a specific directory that things will not change. But now what happens if you lose the node? You need replication for high availability, and you have pods locked into one node. That defines the whole purpose of the scalability that, in my opinion, Kubernetes is giving us. We won't, and I say that not as a provider, but as a user, as a DevOps engineer, we want systems that self-heal as much as possible, please. We don't want to get called at 3 a.m. in the morning, get a call because something is broken, and we can start it somewhere else and we'll be fine. We want systems to self-heal as much as possible and try to do the right thing. So today, with the example that we have seen, we have Rancher that has high availability for the server. So in case of failure of any of the Rancher nodes, you're okay because you know that the Rancher uses that model. We have the Kubernetes control plane that usually runs also in high availability. We have now our pods that if the nodes fail, Kubernetes itself will enforce that they start in a different node. There is a caveat on there. It's called fencing. If anyone has a question about this, I'm more than happy to answer about stateful sets. But essentially, we self-heal as much as possible. And finally, StorageOS has self-healed itself in terms of a node failure. So it just has its own health checks. We fell over a volume. Data is accessible. This in the same line, we need to be able to tolerate losing nodes. In the field, we have different points where things can go wrong. For many years, probably disks have gone wrong the most common with spinning disks. Lately, it happens less with cloud providers and cloud storage systems happens a bit less because, again, there is replication. But we need to be able to have systems that can tolerate losing nodes, and not only losing one node at the worst time possible where other things are going down. So we need to build systems in production to tolerate losing nodes. And finally, in my opinion, anything that you have or what we have seen is there are different topologies to use the application or to provision the application that you use today. Most of them are network-based, meaning they are centralized NFS servers using, for instance, Amazon EFS. They are using, for instance, Ceph or Cluster that are centralized endpoints or centralized nodes that don't move only hold storage. Usually, your workloads tend to be, some of them are okay if my performance is, I don't really need a performance requirement for some of them in terms of input-output operations, but for some of other ones are fundamental. And usually databases, indexes, queues, the latency is fundamental. So your system has to be able to run, in my opinion, in the host where the application is running. Well, pretty much we have the demo done. We broke a few things. Thank you for your attendance, and we're gonna follow with questions. Let me see.
Awesome. Yeah, Farhan, thank you so much. This is Matthew, the host. I'm so glad you went through all that. It was great stuff. And there are quite a few questions. I do want to mention one thing that I saw in the questions, which is some people were asking about Project Longhorn and other high availability storage, and just wanted to mention that we do have another class going for Project Longhorn later this week. So if you do have more questions about that, feel free to join that one. So let's get to some additional questions. So just to start off with some of the fundamentals, you might have already answered this, but Daksh asked, is there a way to create volumes with unique names? For example, if you create two 10 gigabyte volumes for different deployments, how do you know which volume is for which deployment?
Yeah, that's actually, it's easy to see than to explain. We can see, are we referring to read many volumes or read? Well, I'm going to use persistent volume claims anyway. Let's see, let's look into this one. When we create the persistent volume claim, we set a name, right? When we create a volume claim template through a stateful set, let's see, that name is enforced from the stateful set name itself, hyphen the name I added, hyphen 0. If I scale that, we'll have the same hyphen 1, hyphen 2, hyphen 3, and these translate to a persistent volume. I didn't show this because StorageOS usually, well, actually dynamically provisions the persistent volumes. PV. So the PVs, we have a few more, and you can see that there is a mapping this. This is the persistent volume that you can see the name in the StorageOS user interface, which is actually this one. I hope this answered your question. So yes, you can define which names a persistent volume claim has.
Awesome, perfect. Okay, thank you. And actually, now that you have your editor showing, Hemant had asked, what is the add-on, or maybe it's the bash RC script used for the Vim editor that you're using?
Sure. Is this SPF 13, which is quite well-known distribution for Vim. I think you're asking for this, right? It's an SPF 13, and I'm using the Molokai theme, with a bit of customization. Let me see if I'm missing something here. I'm not jumping into conclusion. It's replicated. Yeah, I believe this is the answer. The SPF 13 through Vim that comes with a ton of plugins, which is actually I really like, and I keep discovering new things every day with that.
Very cool, very cool. Thank you. Okay, here's the next one. This is from Salim, who asks, how are you doing session management?
Session management with WordPress happens in the cookies of the browser. So it's not really a session. It's a, let me show you here. Let me move this away. It happens here, 12, in the cookies, application, cookies. Here, WordPress handles the sessions themselves. So pretty much it puts a cookie in your browser when you log in, and that cookie is ciphered and is used through in the WordPress config there is solds, and those solds are used to cipher cookies among other things and the requests. So every time you access that WordPress site, you are able to access. However, many applications don't have this level of statelessness in terms of, so sorry, the main reason for this, let me stop a bit. The main reason for this is, if you don't do this and you don't do it this way, you will need a session store somewhere in your system, right? And I guess this is the question. Usually what I would do, if you need those sessions because you're implementing your own user API OAuth microservice for WordPress, or you're using a, how's it called, one of these e-commerce plugins that need sessions, my highly recommendation could be use Redis for this. You can deploy Redis app. Actually, I can actually show you. We have a use case for Redis. Its deployment stateful set is super easy to deploy, is really lightweight, and then you can configure the PHP itself to use the Redis handler session. So there is a php.ini config that you can specify where the sessions of PHP are stored. You use Redis, it's really easy to configure. You tell the WordPress itself or the PHP that runs WordPress where the sessions are stored, and that's it. I really highly discourage to use the MySQL for that. Sessions are key value store based. It's a model for key value store. If you have a lot of sessions in the database, which is a centralized pool, to say it in a way, tends to add load to database is completely unnecessary.
Okay, awesome. Thank you. Let's see here. Here's a cool question. It's a little bit tangential to what we're talking about, but it might be helpful. This is from Brito, who asks about networking. He says, networking options, Flannel, Calico, Canal, Traffic, Ingress can get so confusing with networking. Can you clarify what you used and any recommendations?
That's a really good question. Rancher by default makes our life really easy in that way. So when I deploy a cluster, and I deploy it, for instance, in GKE, it deploys already with Flannel, which it deploys already with, what I need for networking. So the other thing is StorageOS runs, I can show you here, never mind, runs as a host network. Why? We avoid to use the CNI or the overlay network for performance, and there's other small reasons, but mainly for performance. So we avoid using that. So the interface that we use, the 5705 port, or we use between the 5700 and the 5711 port, those ports are binded to the host themselves. So we can enforce, because we run one StorageOS pod per node, we can enforce that there is one IP only, etc., etc. In terms of networking and ingress, once you have an ingress controller running, it's very easy just to create rules that match host. This is a completely different topic, but and I don't wanna get too diverted. But for me, the ingress is something I really use for test clusters and for development. It's really handy for me. So you put one load balancer, that load balancer in, let's say, in Google Cloud or in Amazon or wherever, is backed by an ingress controller. Let's say you use an Nginx for this, for this, that Nginx default controller will receive those requests from that load balancer, and from there you can specify, okay, for this host I want to go to this Kubernetes service, for that host that other Kubernetes service. So we can decouple through a layer 4 or a layer 7 if we want the networking through ingresses. For the networking of the cluster itself, I have to say that the CNI providers have done such a great job that most often I don't have to worry about it, because as soon as I provide, I provision a cluster with Flannel, or I use Amazon. In Amazon, I use the Canal, which is a Calico plus Flannel on EKS clusters. It usually just works, and unless you need really high-end functionality for TLS or encryption, or you want to change the way the packets look like, or jumbo packets or things like that, things just work fine, as I said, which is actually great.
Awesome. Yeah, and Brito, I'll add too that we do an intro training every Thursday on intro to Rancher and Kubernetes, and that is a great place to ask more about ingress and CNIs, because we do talk about it more there. Okay, let's go on to the next one. This is from Jonathan, who asks, let's say you need to make a quick change to the theme or some other file without using the WordPress dashboard UI. What's the best practice for getting access to the file system and making changes?
That's a good question. First rule of any systems engineer or any DevOps: don't make changes in production. So that's what I was saying before, that usually what you could have is a source control repository that pushes the code into the CI/CD. That CI/CD builds, whether it's Jenkins in Kubernetes, whether it's actually the Rio, or Rancher actually has its own tool for that, which I really like. That CI/CD pipeline builds a container. That container has your changes. From those changes are released to deployment, and the only thing that end up happening from the Kubernetes point of view is something like this. That place. In the CI/CD, there is an imperative command which is called set image that will come here. Instead of using 5.2, it will use something else. Now I'm going to break it, right? But it's going to be 5.3. As soon as this happens, we can see that a new deployment is created. The old pods are running when the new ones, just because I changed the image, just by changing the image, Kubernetes knows that there is new pods. These will start the new ones, and when they are running, it will stop the old ones. Because I just put an image that will break because probably doesn't exist, I don't think they will start. If that image exists, they will start, which actually I got really lucky. So what you can see is this, look. The old pods have gone, the new pods are running. The application is there, the file system, because I mounted the document root, is gonna be there, no problem, just by changing the image. So CI/CD pipeline, make the pipeline talk to Kubernetes to change the image, and when this happens, Kubernetes takes care of it.
Super cool. That was awesome. Okay, here, there's a couple more. This is from Vadim, who asks, what about network limitations reservations? How do you ensure there's enough throughput in a shared network for storage OS? For example, traffic from a node hosting PV to a node hosting NFS, etc.
Yeah, that's a good question. That's a good question. As I said before, we use host network. The network we have is the network we use. If the network is slower, it's saturated, what will happen is that operations are going to be slower. There is no way around it. We are actually implementing a way to use backend interfaces. So for people that run Kubernetes clusters or Rancher clusters in bare metal, we are implementing, this is something is under development right now, to use different interfaces in the machines themselves. So we can use a backbone network to for instance, for our application. What we have seen in our experience is usually good. Why? If you have a really high throughput on the network, you usually need, for instance, in a cloud provider, you need big boxes. Boxes in cloud providers tend to be capped on the network based on the size of the machine itself. So if you have a big box, you have a bigger network or a bigger bandwidth, actually the latency is the same, but you have more bandwidth. On the other hand, what most hurts this kind of input-output operations is not necessarily the bandwidth itself, it's the latency. Why? Because what we're doing is synchronous replication to have high availability. What happens when we put a primary in a different rack, availability zone, data center? Well, we have to wait for a write to happen across the network to be able to acknowledge. For instance, Google Cloud has 0.5 milliseconds latency in between availability zones. So in between data centers, Google Cloud has really low latency, so the performance is really good. Amazon, on the other hand, has 2 millisecond delay in between availability zones in the same region. It depends on the region, so it depends on the AZs. Usually 2 milliseconds is fine. We have seen that people block more on the IOPS of the EBSs than the network itself. And for bare metal, the lower the latency, the faster it goes, obviously. I didn't mention these, but StorageOS is aware of the failure domains. So if we were going to try to place primary volumes and replicas across failure domains, so in different availability zones, different racks, etc.
Okay, thank you. Thanks, Ron. There's a couple more questions. I think these are the last that are in, so we might end with these. And they're both StorageOS specific. I'm not this one from Cornelius. I'm not sure if you'll be able to answer right here, but we'll go for it. He says, We have basically wants to know, can we use Storage OS for this setup? And here's the setup. We have a legacy microservice application with several databases that run on a custom orchestrator with tight coupling to the host storage layer. For backup and sync, we use device mapper snapshots to manage database state. Can we use Storage OS for that in Kubernetes?
Yes. Storage OS, I didn't show you this because it was out of the purpose of the webinar, but Storage OS will use any backend device that you have. So right now, today, I use the file system, the root file system of the Google Cloud boxes. But if you have JBots, if you have any other backend data, you give that to Storage OS. It's a mount point. You give that to the Storage OS directory because Storage OS bind mounts the container to the host. So you can have BMDKs, you can have SCSI mounted endpoints, you can have JBots, etc., etc. As soon as you give that to Storage OS, we will be able to use that backend capacity. For these legacy apps, and now I'm talking a lot without knowing the details, so bear with me a bit here, and I'll try to do my best. Without knowing more about the use case, it's difficult to say, but we are trying to abstract this problem from legacy apps. So precisely, that's what we are trying to do. Avoid that you have to do this kind of lifting yourself, and we try to do that through software. If they want to contact us, they can contact us through Slack. We have in the StorageOS, storageos.slack.com or slack.storageos.com. We're really active there. So these kind of questions there are really, really welcome. So it's something like this, slack.com. So if you go there and just hit us in the general channel, we can go in more details through this use case, but I think it's fair to say that most likely we will be able to help you with that. Of course, if we're using Kubernetes or Rancher or Rancher on Kubernetes or a Kubernetes distribution of any kind.
Awesome, thank you. Okay, cool. All right, here's the last one. This is from Inigo. I'm probably going to butcher your name, but it's from Inigo, who says, what are the advantages of Storage OS compared to a managed FSS like AWS EFS or database as a service like AWS RDS?
That's a very good question. First, I'm gonna try to do that really fast, but it's a long process. Let's say you want to provision an EFS in Amazon. First, you need to create a security group. Well, security group. First, you provision the EFS. You don't know how much capacity, but you just randomly say, let's say 100 gigs for that EFS. Now, you have a file system ID. That file system ID needs a security group in between the nodes and that file system ID. So you have to deploy that FSID in a way, in a network area that is accessibly mountable by Kubernetes. Second, or actually before that, you would also need the tools in Amazon to mount EFS volumes. Then you have to go to Kubernetes and have the CSI provisioner. CSI provisioner is a way to glue or to connect Kubernetes to other storage providers or storage interface. In this case, you would have to deploy one yourself because in StorageOS we're doing that for you. So when I run StorageOS and that daemon set already has the CSI helpers or the containers that interact with Kubernetes, then you have the FSID. You have deployed one pod per node of the CSI container, one pod per node of that CSI container. Then you create a persistent volume. That persistent volume has the reference to the file system ID and the URL of the EFS. When you have done that, you create a persistent volume claim, similar to what I showed you today, and you reference that persistent volume in Kubernetes. Cool. That is going to take you half a morning. If you have it automated, maybe with the IAM roles and the security groups, and you have Terraform tools and things like that, and the AMIs that you're using already have the tooling to mount EFS volumes, maybe it will take you for every volume you provision a couple of hours for every single persistent volume claim that you create. What we're trying to do here is that you can create persistent volume claims under demand, and if it's read many as well under demand, it takes a bit longer because we have to start the pod, but there is a control plane that controls this kind of logic, right? So for the EFS, it's painful. I've done it, and I've done it for a while. It's really painful. And one of the main reasons we built that solution is because people were asking us massively in the community, please give us something that we can use and is better. What is it out there? So a read many volume is something we have developed, and it's in beta now. Even I use it today. It's in beta as a tech preview because of people in the community asking us for. So the other component is the performance. The performance of EFS depends on the amount of data that you use, not the data that you provision. EBS is the amount of data that you provision or capacity you provision. EFS is that you use. So unless you use the whole capacity of that EFS, things get really, really slow. You can try. I'm saying that because of my own experience, but more than happy to for anyone to say otherwise or test it themselves. But the way it works, it usually pre-warms the caches for the EFS. The bigger the EFS, the more backend IOPS you will have, but you will have to fill it first. So I've even seen people using EFS having to fill the whole EFS volume to be able to start using it with some performance, some predictable performance. On the RDS point of view, something is a bit different, but it's a bit some of the things that for RDS are similar. As I said before, RDS is a great tool. It's a bit expensive if you have used it a bit, and you will have one RDS, one big instance of RDS or two with replication. You might use Aurora, and you have a few replicas. Meaning, if you have 10 applications in your Kubernetes cluster, you probably will have one or two RDSs all sharing the database. When you use PVCs and you use Kubernetes internally, you can change the paradigm. You can have these big ass instances or database instances that don't move, which is all right. We do node selectors and affinity and things don't move and nothing else runs there, etc. Or you can have many small ones. You can actually start building a system where you have databases for staging or for development that are cloned from production, that don't have to be that stable, that you can stop and start whenever you need them. The productions one are stable and have high availability, as I show you today. And the other, so from an operational point of view, you can choose. It's going to be cheaper. Yes, RDS gives you some sort of, or gives you the managed service point of view, how's it called, to backtrack the way that you can use the transaction log to recover from a snapshot, which is great, backups and things like that, but you pay for it and you pay a lot of money for it. Second component or the second point of that could be the networking. To use RDS on Kubernetes is not difficult, but again, you have to play with the security groups. If you're running in different VPCs, which most likely happens if you use EKS, EKS usually runs in nodes in its own VPC, or in a different one. Even if you have like 3 different clusters, they run in the same VPC, but a different one from RDS. So you have to start peering the VPCs. There is some lifting to be done that is not obvious to at the first glance, that tends to be painful. Yet is a good solution in my opinion. And sorry for the long talk, but it's a big topic.
Yeah, it's a big topic, and I really appreciate you being thorough. It's no problem at all. But I do think we're near the end of our time. There is another question I see from Jonathan about CI/CD in WordPress and Kubernetes. Do you have a short answer? He just asked for recommendations for your favorite tools for CI/CD and WordPress, and we'll end it there.
Yep, I am a big believer of simplicity, and the Jenkins for me is super simple. If you need something a bit more sophisticated, there are paid options as well with JFrog. But we actually have a use case in the repo I show you today, which I'm more than happy to share around. That is public. This is how they deploy Jenkins using storage as backup volume. And from there on, we actually have a use case example in our documentation page. So really fast, docs.storage.com, use cases. Here it is, Jenkins. That is really easy to use and actually allows you to use, if you want to create jobs as pods, there is a fantastic plugin for it that lets you create different builds, deploying different pods rather than saturating one node. So you can start creating slaves very easy, etc. So yeah,
Super
pretty
cool.
much that's it. There are many CI/CD options that are really good. Rio is really nice. So Rancher, if you use Rancher internally, the pipelines in Rancher are really nice. Also, you can go across clusters, across namespaces. It's really, really nice and very nicely integrated as well.
Awesome, awesome. Okay, cool. Well, I think we'll leave it there. Anything else you want to let us know, Farhan, before we wrap up?
I just want to thank you all for attending. If you want to hit us in the Slack, any questions that are pending or anything you want to know, just let us know. I'm there quite often, my colleagues as well. Also, thank you to the Rancher team to allow us to give us this opportunity to show this. I'm really, really happy about it. I really like the Rancher project as well, and I use it internally myself almost every day. So thank you for that great tool as well.
Awesome. Yeah, you're welcome. I'm happy for you to be here. And like I mentioned before, if you do have more storage questions, persistent storage questions, we do have another training coming up this week. So check that out on rancher.com/training. And as I also mentioned, this is recorded. So we will send out the recording and the slides after this training. Again, Farhan, awesome job. Thanks, everybody. Have a great rest of your week. Talk to you all later.
Thank you. Bye.